Hi guys, this is Mrs. Foy, and this is a quick screencast on doing simple Stoich problems. So on your pair deck, hopefully you have been at least be able to look at some of these problems, and we're going to start off with looking at our mole map, right? So our mole map is right here. These are all the different ways that we know to get to moles. That's really important in a Stoich problem to be able to get to moles. So I want to show you that there is a new way to get to moles that you've never seen before today, and that is the equivalence of 1 mole of any gas, doesn't matter what gas it is, under certain conditions, which I'll explain in a minute, is always equal to 22.4 liters. So that would be like a big beach ball kind of thing. And the conditions are that the gas has to be at STP, which stands for standard temperature, which is 0 degrees C, and pressure, which is one atmosphere, which is about the pressure that we have on us right now, atmospheric pressure in York, PA. So here's my problem. What is the volume of the balloon at STP if you have 5.5 moles of it? So this only works, this shortcut mole conversion only works under those conditions, but I'm going to try to find the volume of the balloon. So if I want a single unit, I start with a single unit, and I have 5.5 moles of helium. So I'm going to use this new equivalent. This 1 mole of any gas is equal to 22.4 liters. So 1 mole goes on the bottom, 22.4 liters goes on the top, moles cancel. And then I have my handy dandy calculator, and that would be 123.2 liters of helium. Okay, so that's how you convert back and forth. Unless it says STP, you can't use that conversion. If it doesn't say that, you have to use something called gas laws, which we'll talk about later. So we're going to start out doing some very simple Stoich problems, and these are simple because the chemical equation is already balanced and everything is already in moles. So that's going to make it nice and simple for us just to start. So remember, if things weren't in moles, you would have 4 different ways to get to moles. And you know about all of these different ways. The only way that is new to you is this conversion. Okay, so you know how to get back and forth from mass to moles. You know how to get back and forth between number of particles and moles, Avogadro's number. And even though you might not like to remember, you know how to get back and forth using molarity. So those are the different ways you can get to moles. But for these first problems, we're just going to already be in moles. So the rules for making Stoich problems successful. The first thing is that you have to start with a balanced chemical equation. The second thing is you're going to diagram the problem, and I'm going to show you how to do that. You're going to make little boxes and put the data from the word problem into the boxes so that you can actually see what you're comparing. The next thing is you have to get everything in the problem into moles. You might have to use that mole map, but on these problems, I've already done it for you. You're going to solve for the unit asked for in the problem. And if it is a limiting reactant problem, if they give you the amounts of 2 different reactants, then you have to actually do double the work. You have to do 2 Stoich problems in order for it to be able to be solved. So here is our first problem. If we have 5 moles of aluminum chloride, so I'm going to diagram this now. Well, first of all, my equation is balanced. I can see that everything is balanced here. If it's not, you would have to balance it. But I'm going to start out with aluminum chloride, and I'm going to say if 5 moles of aluminum chloride reacts with an excess, so I'm just taking the word problem and I'm just kind of diagramming it. This excess means that I have plenty of this stuff, So I basically get to ignore it because I'm not going to write out of it. It tells me that in the problem. But it says how many moles of lead 2 chloride will form. So over here, I'm going to have a question mark moles because that's what I'm solving for. So I've diagrammed my problem, and I can see that what I'm going to be doing here is I'm going to be comparing this ratio to this ratio. I'm going to use my coefficient, so I have a 2 to 3 ratio that I'm going to compare there, and that's how I'm going to do my Stoich problem. So here I go. I want moles of lead 2 chloride. If I want a single unit, I'm going to start a single unit. So I've got 5 moles of aluminum chloride to start. So what I'm going to do now is I'm going to look at my ratios. I'm going to look at this 2 and I look at this 3, and then I'm going to set this up so that I have what I want to cancel on the bottom. So I'm going to write 2 moles of aluminum chloride on the bottom. That's where I got this 2, is from the balanced equation, the coefficient. And then on the top, I'm going to put 3 moles of lead 2 chloride on the top. Now look what I get to do. I get to cancel out my moles of aluminum chloride and moles of aluminum chloride. And I have moles of lead 2 chloride, which is what I want. So I'm done with my problem. And now on my calculator, I'm just going to say 5 times 3 divided by 2, and my answer is 7.5. So that's my first simple Stoich problem. All right? So let's try another one. Do I have a balanced equation? Yes, I do. Now I'm ready to start diagramming my problem. And so my question says here, it says, how many moles of hydrochloric acid? So I'm going to put a box around hydrochloric acid and put a question mark moles, because that's what the word problem says, would be needed to react with 2 moles of calcium hydroxide. So I'm going to put a box around calcium hydroxide and put 2 moles. So now, clearly, I'm going to be comparing these two things. And the mole ratios that I'm going to be looking at are going to be 2 to 1, right? So I'm going to be comparing these two things for my mole ratio. So now I'm ready to go because everything is already in moles. Look, moles, moles. So this is going to be easy. So what do I want? I want moles of hydrochloric acid. If I want a single unit, I'm going to start with the single unit. So I'm going to start with the only other piece of data in my problem, and that is my 2 moles of calcium hydroxide. So now I need my mole ratio. So now I'm going to look at this 2 to 1 ratio, and I can see that I want moles of calcium hydroxide on the bottom. So the 1 comes from the fact that there is a kind of an invisible 1 there in front of that balanced equation. And so my moles of calcium hydroxide are going to cancel. So on the top, I'm going to put 2 moles of hydrochloric acid because the balanced equation tells me that there's 2 moles of this for every 1 mole of this. So now I use my factor labeling skills. Moles of calcium hydroxide cancel. I get moles of hydrochloric acid, which is what I want, so I'm done. And I'm just going to say 2 times 2 divided by 1, obviously, is 4. So my answer is 4 moles of hydrochloric acid. So this one is going to be a little bit different because I'm going to be given the amount of 2 different reactants. I've got a balanced equation, everything's in moles, but this one is going to be a limiting reactant problem, and I'll show you in just a minute how you can tell that. And I'm going to do this in 2 different colors. So I'm going to diagram, it says 0.8 moles of aluminum, so I'm going to put a box around here and say 0.8 moles of aluminum here. And then I'm going to do this in a different color, and you'll see why in just a minute. It says 0.6 moles of sulfuric acid, so I'm going to put that amount here. 0.600 moles of that here. And then the question says, how many moles of aluminum sulfate am I will I form? So basically what's happening here, guys, is that we're going to be doing a blue problem that is going to look at this ratio, the ratio of 2 to 1. And then the other problem is going to be looking at this ratio of the sulfuric acid with my product, and I'm going to be looking at a 3 to 1 ratio there. Okay, so I'm going to let you just look at that for a second. So I'm going to be doing 2 mole problems here because I don't know which thing I'm going to run out of. I'm either going to run out of the aluminum, or I'm going to run out of the sulfuric acid. I don't know. I got to figure out which one is going to run out first. So I'm going to do my blue problem first. And I know that I want moles of aluminum sulfate. Okay, I'm going to do my blue problem first. So I want a single unit. I start with a single unit. 0.800 moles of aluminum. And now I'm going to look at the ratio of aluminum to aluminum sulfate. And I see it's a 2 to 1 ratio from the coefficients in the balanced equation. So 2 moles of aluminum for every 1 mole of aluminum sulfate. And I see that my moles of aluminum cancel. And I have moles of aluminum sulfate, which is what I want. So I'm going to take 0.800 divided by 2, and that's 0.4 moles. All right, so that's my blue problem, but I'm only halfway done. So now I'm going to do my red problem. I'm still trying to find out moles of aluminum sulfate, but I'm going to try to figure out now how much I can make with my other reactant, which is sulfuric acid. So I have 0.600 moles of sulfuric acid. And now I'm looking at the ratio of the sulfuric acid to the aluminum sulfate. And so I'm going to use a 3 to 1 ratio. I'm going to use my factor labeling skills to recognize that I want to put the sulfuric acid on the bottom and the 1 mole of aluminum sulfate on the top. Moles of sulfuric acid cancel, and I have aluminum sulfate on the top. So this one, I'm done. 0.600 divided by 3, I get 0.2 moles of that. So now we need to kind of look at this because it seems a little confusing at first. Am I going to make 0.4 moles of aluminum sulfate or 0.2 moles of aluminum sulfate? And the answer is I'm going to make the least amount because I am going to run out. This is how much I'm going to make because I am going to run out of the sulfuric acid that was one of my reactants. So this is going to limit me. This is my limiting reactant because the sulfuric acid is going to run out. I'm only going to make 0.2 moles of my product. I have enough aluminum to make twice that much, but I'm going to run out of sulfuric acid when I make 0.2. So this is just like the PhET simulation that you use when you were trying to make sandwiches and you were trying to figure out how many sandwiches you could make if you were going to run out of cheese or run out of bread. In this case, I'm going to run out of sulfuric acid when I make this much product. I'm not going to make 0.4 moles because I'm going to run out of one of my reactants when I make that much. All right, let's try this one. How many moles of iron 3 oxide? So I've got a balanced equation, and it looks like 2 things are in moles, but this time it's asking me liters of gas will form. It says how many liters of gas will form, but I'm going to convert, and that's not going to be a big deal. So let's go ahead and diagram the problem. So here I have going to put a box around that reactant, 4.5 moles of that. And then I'm going to, I have information about my other reactant. I'm going to put that in a different color just to kind of help me not get lost in the problem. So I have 3.8 moles of that. And so I can see that this is going to be another limiting reactant problem because it's asking me how many moles of carbon monoxide gas will form. So I have to figure out, well, if I use up all my 4.5 moles of Fe2O3, how many liters of this am I going to make? And I'm going to go to moles first and then convert. And here is my second problem. I'm going to say, well, if I use up all of my carbon, how many moles of carbon monoxide am I going to make? So this is a limiting reactant problem, and I'm going to start with the red problem first. Okay, so here I go. I'm trying to find liters of carbon monoxide. So I'm going to start with 4.5 moles of my iron oxide, my iron 3 oxide. And so what is the ratio I'm interested in now? Well, I'm interested in the ratio between this reactant and that product. It's a 1:3 ratio. And because of factor labeling, I know I want the 1 mole of Fe2O3 on the bottom and the 3 moles of the carbon monoxide on the top. Now, I need liters, and so this is how I get from moles to liters. I know that at STP, 1 mole is equal to 22.4 liters. So I just have to very quickly convert moles of carbon monoxide gas to liters. All right, and so my moles of Fe2O3 cancel, my moles of carbon monoxide cancel, and I have liters. So I would say 4.5 times 3 times 22.4, and it's just divided by 1. So I would actually get 302.4 liters, that's a big balloon, of carbon monoxide. All right, so now let's try my blue problem and see how much I can make, how much carbon monoxide I can make if I use up all of this. I'm still solving for liters of carbon monoxide, but this time I'm going to start with my other reactant. I have 3.8 moles of carbon, and now I'm interested in the ratio of this to this, right? The carbon to the carbon monoxide, which is a 3:3 ratio. So I put the moles of carbon on the bottom, so it cancels, and I have 3 moles. And you don't need to reduce it because it's just, obviously it's just 1, but you're going to leave it just like that. So my moles of carbon and moles of carbon cancel. And now I'm in moles of carbon monoxide, but I want liters, and so I have to use that 22.4 liters for every 1 mole of carbon monoxide, so that cancels. And now I am ready to solve for that. 3.8 times 22.4, and I get 85.12, let's say just 0.1, liters of carbon monoxide. So now we get back to the other situation that we talked about before. We said, okay, well, am I going to make 85 liters of carbon monoxide or 302 liters of carbon monoxide? And the answer is that you pick the least amount of the product because that means you are going to run out of one of the reactants. So what that means is this, guys. That means that if I use up all of my moles of carbon, if I use up every little scrap of that, I can only make that much carbon monoxide. If I use up all of this reactant, I can make 302 liters, but I'm not going to make that much because I'm going to run out. I'm going to run out of carbon before I make 302. I'm going to run out of carbon when I only make 85. And so carbon is my limiting reactant, all right? And so my answer is 85.1 liters of carbon monoxide. So hope that's been helpful, and I'll see you in class.